Hello and welcome to the Chemistry 106 lab on sugar concentration. In this lab we are going to look at the different concentrations of a sugar solution based on the influence of a hydrometer. Okay. And of course I forgot to do something first, so we need some way to record our data, right? So first what you would have to do is you'd have to build a hydrometer. I already have one in there because the water one is sort of picky. So you take this is a rudimentary way to build this, but it will work for purposes of today's lab. So you take this pipette, you take a nail with a washer, and you shove it straight through the bottom, trying not to hit any other plastic once you puncture or to pull it back out. Okay, this should create a watertight seal. And then what I did is I put enough water in here to fill up about 1 centimeter. Okay, and then what we've done here is we've suspended this in a purified water solution, which is our 0%. So for 0%, we're going to measure the amount to which our water-filled hydrometer floats in each solution, and that will tell us the concentration based on the relative buoyancy. So once you've got that set up, we're going to put our ruler up against it and measure the water line to the top of the pipette. So this one's sort of hard to see because of where it ended up, but it looks like our water is at 26 millimeters for 0%. Okay? So for each of the rest, we're going to use different sugar solutions. And we're going to pour approximately 50 mils of each sugar solution into the graduated cylinder. I'm going to go ahead and do that now. So that's our 4%. And then our 8%. And these have been pre-made. These are our standards. We're going to use these measurements to build a standard curve. And then based on the results of our unknowns, we should be able to predict what the relative sugar concentration is by comparing it to the results that we get from knowns. This is a standard analytical technique to use knowns to build a standard curve and then to compare your results to a known. Now, it's not completely accurate because there are other things that may cause buoyancy, but for purposes of this course, it will suffice in terms of giving us a more or less accurate picture of the relative buoyancy. Okay, so we have on the far left side, we have a 0%, which is purified water, and then we have 4, 8, 12, and 16% sugars. Okay, so we're going to take this same hydrometer and rinse it and blot it. I'm not going to rinse this one because it was just in water. The reason why we want to rinse is we don't want to contaminate it. And that's why we're also going to move from 4% up, because the amount of contamination will be minimized that way. So we set this in here gently, and then we measure the distance from the top of the water line to the top of the pipette. And of course, it's not easy to see. So that is 28 millimeters. Okay, and somehow you got to get it back out of here. Says, no, I want to stay. And we want to rinse it, just to be sure, blot it. And then we're going to put it into the 8%. And then again, we're going to measure from the water line to the top of the pipette. And that is 31. These fat fingers that don't go in there very well. I have to get some forceps. And the reason why we're using the same hydrometer is because it will be consistent between them. And that way we know that all that we have modified is the solution it's going into. So this is the 12% sugar solution. Oops, if I haven't turned the right direction. And that's 36 millimeters. And rinse. And blot. And then we set this back into our 16% and then measure the distance. Not linear. That's okay. It's, you know, more what you call a guideline than actual is. Okay? So we'll use that information to build a standard curve. So what I've set up for you here is we have that the 0% was 26 millimeters, 4% was 28, the 8% was 31, the 12% was 36, and the 16% was 38 millimeters. Okay? And that's the distance from the top. Now there's maybe some variation because I use different cylinders. It might have worked better if I used the exact same one. What I'm going to do now is I'm going to set up some unknowns. We're going to set them up with 50 mils again in each tube. And then I'm going to use this exact same hydrometer that I just rinsed in order to measure the distance, and then we'll know the measurements of our unknowns. All right, I have some unknowns here that are ready to be measured. From left to right, we have lemon juice, lemonade, Diet Pepsi, and cranberry juice. And ordinarily, for purposes of demonstrations, we don't use brand names, but Pepsi may be different from Coke, so it is important to differentiate, or generic cola, RC Cola, whatever the brand is, because they may vary between them, each of them having their own particular brand and branding. And so we're going to take our hydrometer from before, which I have cleaned and blotted, and we're going to put it into our lemon juice first, and then we'll measure the distance between the top of the liquid and the top of the pipette. And that is 32 millimeters. Okay, so we remove it, and rinse it, blot it, and then use it again. Like I said, we're using this same one because that way what we're putting in is consistent. The only thing that's different is what the juice is we're inserting our hydrometer into. So this is our lemonade. Holy cow. Now there's some viscosity in here because this actually has pulp. So we're going to let it sink here just a little bit more than usual, just to make sure that the pulp is not holding it up. So you might want to use a pulp-free one, I guess. Word to the wise in the future, so that is 31 millimeters. Once we clear the pulp, anyway. So there's some question about whether that's accurate or not because of the presence of the pulp. Also should have done that one last because now I got to make sure I clean the pulp off, because the pulp will now add mass. And if I don't clean it all off and weigh down my hydrometer. Okay, so now we're ready to put it into our Diet Pepsi. Now remember, diet means sugar-free, or well, calorie-free, not sugar-free, as you can see. There's at least something that's sort of sugary dissolved in there, and that's 25 comport with our 0% sugar. So there's something in there causing buoyancy, but it is not sugar. Okay. So our hydrometer did show that Diet Pepsi has no sugar. And here's our cranberry juice. Oops, let me block this off first. I usually add sugar to cranberry juice because otherwise no one would drink it. And that is 34 milliliters. All right. That concludes the data collection. To recap, here are the results. So our 0% solution had 26 millimeters. Our 4% was 28. Our 8% was 31. Our 12% was 36. And our 16% was 38 millimeters. The lemon juice was 32 millimeters. So you can see that corresponds very close to this. Lemonade was 31. Diet Pepsi was 25. Cranberry was 34. So build a standard curve, use that information to deduce, calculate the sugar concentration of each of those substances. And then I believe you are finished with the data collection for this lab. Good luck with the rest of the semester. Thank you and take care.